we learn PID configuration and parameter settings for PLC. Today, we will learn about programming using PID control through a factory sewage treatment, specifically, the circulating pool liquid level of a workshop section. Firstly, let's take a look at the control requirement. As shown in the figure, the liquid level control of the circulating pool in the factory sewage treatment section is carried out. This liquid level sensor is used to detect the liquid level in the pool, and an electric regulating valve is used to adjust the flow rate of the liquid level. The height of the circulating pool is 0 to 8 meters, and the sensor output is 4 to 20 milliamperes. The regulating valve can receive 0 to 10 volts and adjust the valve opening to maintain a constant liquid level in the circulating pool. Please design a corresponding PLC control circuit and create a program. I/O diagram of PLC circuit. As shown in the figure, it is the I/O wiring of a PLC. As the sensor output is 4 to 20 milliamperes, it outputs analog input to channel 0 of IA, analog output to channel 0 of AQ, and a voltage of 0 to 10 volts to control this valve. Next, let's look at the hardware configuration. 1. In the view of a set of devices, we select PLC. Then, we realize regular analog quantity input and select channel 0. The address is IW64. Channel 0 is selected for analog quantity output and the output address is QW64. Add a new variable table. 3 variable symbols are used to define variables, which are target value, feedback value, and output value, as shown in the figure. 2. Configure the interrupt organization block, OB30. In the project program, double-click New Block, click Organization Block, select the organization block in the middle of the cyclic program, which is numbered 30. We can modify its scanning time to 500 milliseconds. Of course, we can also modify the time interval in the middle of the cyclic program in the properties of OB30. 3. In the middle of the cyclic program OB30, we need to call the PID instruction. In the main program OB view, find the PID control instruction in the process instruction and drag it to the OBE program. 4. PID parameter settings. Configuration parameters need to be set when using PID controllers, generally including 3 parts, namely, basic setting, process value setting, and advanced value setting. The interface is shown in the figure. The basic setting is to set the type of controller, which is divided into set values, process values, and disturbance variables, and select physical quantities and measurement units. Logic is reversely controlled. If this is not selected, then the PID circuit is in direct action mode, which means that when the input value is less than the set value, the PID output will increase. If this option is selected, when the input value is greater than the set value, the output of the PID circuit will increase. There is also a PID restart mode, which needs to be selected sometimes. Another basic setting is to define the content and data types of PID process values and output values. First, define the input and select the input per or in-out parameter for the process value. Here, we recommend that you choose the input per parameter. We select output per parameters or output parameters when defining output value. We recommend output per parameters. Secondly, it is process value setting, process value limiting and calibration. The input value must be within the limited range. If the process value is below the lower limit or above the upper limit, the PID circuit will enter inactive mode and set the output value to 0. To use input per, the process value of the analog input must be calibrated. For example, the lower limit of the process value corresponding to 5530 of the digital quantity is 0%, and the upper limit of the process value corresponding to 2764 of the digital quantity is 100%. Perform calibration on the output value. The lower limit is calibrated 0% and the upper limit is calibrated 100%. The lower limit of the analog quantity is 5530 when the input analog quantity is 4 to 20 milliamperes, corresponding to 0%. The upper limit is 27,648, corresponding to 100%. Advanced settings. The output value should be limited. In the limit window of the output value, Configure it in percentage, and the output value and limit value should not be greater than the limit value of this output value, whether in manual mode or automatic mode. The advanced settings require manual input of PID parameters. In this PID configuration interface, we can modify PID parameters. Through this configuration interface, we can modify the parameters. After modification, we need to download again and restart the PLC. Fifthly, its address allocation for parameters related to PID function blocks. Firstly, the target value is selected. The controller type in this project is usually configured normally, with a target value range of 0% to 100%. Here, we set it to 70%. The input process value is configured as input per, and the process value input is actually the address of the analog input. Here, we set as IW64. The activation of manual mode can be achieved through internal Boolean variables in the PLC. The output of manual mode is set by variables stored in the global data block, typically ranging from 0 to 100% or 0.0 to 100.0. Let's set the PID output value. What should be selected for the PID output value for this project? Select output per, and this case is set as QW64. This completes the lesson. See you next time.